Hello everyone, I am Professor Amit Solanki. Today we will continue our topic, that is the DC motor drive. In previous class we have discussed the syllabus topics and content of the second unit for the subject PECD, and in that we have started the introduction about the DC motor drive. What are their specifications? Now in that lecture we will continue from previous lecture. So let us understanding what is the specification, or what are the types, what are the torque, speed, and the equations for the DC motor drive. As you have see in this figure, okay, this is the types or classification of DC motor drives. So basically DC motors are classified in four types. One is separately excited, shunt, series, and cumulative compound. Okay, these are the basic four types of DC motor. Now in this slide you can see the basic equations for the DC motor. So before go to the deep knowledge of the DC motor drive, we should have to know about the basic equations for the DC motor drive, or we can say that the basic concept for the DC motor. As you have in previous class you have already studied the subject like electrical machine 1 and 2. In that you have already gained the knowledge about the motor, or we can say that a DC motor. So for that, today we will discuss the basic equations and specification of the DC motor drive. Okay. So first in that slide you can see here, this is the first equation, that is the E. E is equals to K of E phi omega m. Second equation, that is the V. V is equals to E plus IA RA. Third equation, that is the T, that means torque KE phi IA. As you know that phi is the flux, IA is the armature current, RA is the armature resistance, K is the constant. So in that, according to above equation, we can say that the values for these equations of the terms associated with that, where phi is the flux per pole in the Weber, where IA stands for armature current in the ampere, V is the armature voltage in volt, R of A is the resistance of the armature circuit, denoted by the ohm, and omega m is the speed of the armature, is given by in radian per second, and capital T means torque developed by the motor in the Newton meter, and K of E is a constant. So these are the relations and terminologies which is associated with this about three equations. From the equation 2.1 to 2.3, we can write the next equation, or we can find out the speed formula for the DC motor. So from above three equations, we can write here omega m is equals to V upon K phi minus RA upon K phi IA. Or we can arrange, or we can rewrite this equation again in the form of, that is omega m is equals to V upon K phi minus R of A upon K phi ka whole square into T. So we can say that equation 2.1 to 2.5 are applicable to all three types of DC motor. Okay, so you can got it this point, you can point out this equations. So these are the 2.1 to 2.5 equations are these all equations are applicable for the all types of motors like separately excited, shunt excited, series, and compound motor. These are the basic equations or relations associated with the DC motor. Now we can look here, we can understand the steady state speed torque relation. Our main objective of this unit is to how to control the speed of the DC motor. So for that, we required the speed torque characteristic of the individual or particular motor. So in that equivalent circuit, you can see here equivalent circuit of the armature circuit of the DC motor. Like in that, there is a battery is connected and there is resistance is connected Ra in the form of, you can see here, this is the armature which is given by E is equal to Ke phi omega m. So steady state equivalent circuit of the armature of DC machine is shown in figure, above figure. Okay. So according to that, we can say that resistance R of A is the resistance of the armature circuit. For separately excited and shunt motor, it is equal to the resistance of armature winding. And for series and compound motor, it is the sum of armature and series field winding resistance. So this is the relation between speed torque. In that case of separately excited motor, that means if you are talking about the separately excited DC motor, so in that separately excited motor, if the field voltage is maintained constant, okay, one can assume that the flux is practically constant as the torque change. So let us assume this equation according to this above statement. So that will be Ke phi equals to K, which is the constant. Then the from equation 2.1, 2.3 and 2.4 to 2.6, we can go through it and find out the next equation, that is the torque T, capital torque T is equals to K of Ia, where K is the constant, Ia is the armature current. So that means torque is depends on the armature current and the K constant. Now we can write the EMF equation is equals to K of omega m. Now according to this above equation, we can rewrite the speed equation, that is the omega m is equals to V by K minus R of A upon K into Ia. Also we can rewrite in the another form of this equation like V of K minus R of A K square T. We can put this value of the I in this equation. So we can find out the new value, new formula for the omega m, that is the V upon K minus R of A upon K square into T. So this is the steady state speed torque curve. In that figure in the slide, you can see here, this is the speed torque relation, speed torque characteristic of the different three motors. The speed torque characteristic of separately excited motor is a straight line. In this figure, you can see here, you can observe here, the separately excited motor DC motor characteristic is looking like as a straight line. Okay, the graph is plotted between speed and torque. So you can observe here the speed torque curve of the DC motor. We have tried to understanding here the three motors characteristic in a single figure. And the no load speed omega m0 is determined by the values of the armature voltage and the field excitation. That speed decreases as torque increases, and speed regulation depends on the armature circuit resistance as per the equation 2.10. In practice, due to armature reaction, the flux decreases as torque increases, even when the field current is kept constant. So this is the all about the speed torque curve of the DC motor. Okay, so these are the all about the concept of our today's lecture. Now, thank you for watching this video.